chapter 2 for Math 162 students, and you can see we have in this video we'll be doing normal distribution, and we have the subtopic. We have introduction to normal distribution, standard normal distribution, the empirical rule, calculating probabilities, application and importance. Then we come to the conclusion. So what is a normal distribution? What is normal distribution? Those of us that watched the last video, you notice that I already explained the part where I told you that normal distribution is a continuous distribution. I told you we have discrete probability distribution function and continuous PDF. So normal distribution happens to be one of the continuous distribution that we have, and most times it is often called the Gaussian distribution or the bell curve. It has a bell curve. That's the shape of the normal distribution. So it is one of the most important continuous probability distribution that we have in statistics. So it models a wide variety of natural phenomena such as height, blood pressure, and the likes. Now, we have the key characteristics of normal distribution. It is symmetry, that is, it is symmetric in nature. The mean, the median, and the mode, they coincide, that is, they come together. I get it. So they are also asymptotic in the sense that the deviation, that is the tail, never come to meet each other. Now I believe that most every one of you that you are currently watching this video, you've gone through the PDF that is sent on the platform concerning the graph. So those of you that have not seen the graph of a normal distribution, how the graph of a normal distribution looks like, you should check the PDF. Now we have normal distribution. We also have what we call the standard normal distribution. They are two different things. In fact, their graph varies. The graph look alike, but they are different. But we get to standard normal distribution as time goes on. Now, parameters of the normal distribution: we have the mean and we have the variance. Now the mean is that symbol. The symbol is called nu or nu. Some people call it mu. Are you getting it? So it represents the center. So if you look at the graph, the center line is called the mean. Why those two tail? You see that the graph has two tail, one to the left and the other one to the right. So the two of them, they are called the variance. Variance means that they are moving away, they are different. Are you getting me? So the variance represents the spread of the dispersion of the data points around the mean. So the variance is sigma squared. That symbol is sigma, the other one is mu. Are you getting me? So we can say that in notation form, we can say that that last point that I wrote notation, you read it as S is normally distributed to the mean, comma, the variance. I repeat, X is normally distributed to the mean and the variance. So that symbol that you have at the bottom line represents that S is normally distributed to the mean and what? The variance. So the mean represents the center, while the variance represents the spread. So a smaller mean, a smaller variance means that the shape of the graph is going to be very narrow, but a taller curve, the curve will be taller. So if you have a smaller standard variance, now back to the probability density function. The probability density function for normal distribution has a formula. So it is called the PDF. The PDF of a normal distribution has a particular formula, and it is f of x equals to 1 over sigma square root of 2 pi e raised to power minus 1 over 2 x minus mu over sigma all squared. So that is what we call the PDF of density of normal distribution. So you can be asked to recognize or signify which of the distribution is normal. So you must know that formula and you must recognize it. So the function described that there is a relative likelihood for x to take on a given value Are you getting me? So you see that we have a value of x, we have sigma, we have standard deviation, we have pi, and we have e. So these are some of the variables that are present in the PDF of a normal distribution. Are you getting it? Now, what is a standard normal distribution? As I stated earlier, there's a difference between normal distribution and standard normal distribution. Now, a normal distribution becomes a standard distribution when the mean is equals to 0 and the variance is equals to 1. Are you getting me? The variance is equals to 1. When the variance is equals to 1 and the mean is equals to 0, a normal distribution then becomes a standard normal distribution. So you can see question like this, that when do a normal distribution become a standard normal distribution? So there are two conditions that are involved before you can convert a normal distribution to a standard normal distribution, which I already stated. Are you getting me? So in the PDF means probability density function. Are you getting me? So the random variable for a standard normal distribution is commonly denoted by z. So for a standard normal distribution, we usually represent it with z. But if it is a normal distribution, we usually represent it with x. Are you getting it? So don't forget that the variance is the square of the standard deviation. The variance is the square of the standard deviation. So it means that if the variance is equals to 1, the standard deviation it will also be equals to what? 1. Are you getting me? 1 raised to power 2 is still 1. So now, by simplification, by applying 0 and 1 to the function that we stated earlier, let's go back to the function. The function that we stated earlier was 1 over sigma square root of 2 pi e raised to power minus 1 over 2 x minus mu over sigma all squared. Now we want to represent the value for mean, which is mu, to be equals to 0, and the value for the standard deviation, which is equals to 1. If we substitute it back into this point, then this normal distribution will change its form entirely to a standard normal distribution, which we now have here. So you can see that we now have entirely new function. So we have file of z. That symbol that you have there is called file. The other one is f. This one is file, and it is having z now. Are you getting me? It is having z because it is no longer a normal distribution, but it is now a standard normal distribution. So that's why we have the symbol z to be there. So it now becomes 1 over square root of 2 pi. Now you notice that the sigma that we have in the other one disappears because it is now equals to 1. Are you getting it? Now e raised to power minus 1 over 2 z squared. Now all of those things that we have has now become z. They are called the z score. Are you getting me? I mean, x minus mu over sigma, we represent all of them as z. It is called z score. So in representing a normal distribution as a standard normal distribution, we substitute x minus mu over sigma as z. So by substituting that, we now have a standard normal distribution, which is this new function that we have. So this distribution is crucial because tables and softwares often provide probabilities for the standard normal curve. So most table that we have these days, they usually provide distribution for majorly standard normal distribution because it is standard. So now, standardizing a z-score transformation. What is a z-score? A z-score is what we extracted from the normal distribution, the power of the exponent, the power of the e value, the power of the e value that was extracted from a normal distribution down to a standard normal distribution is the z-score. And it is x minus the mean divided by the standard deviation. Now, what is the purpose of the z-score? Why do we have the z-score? The z-score measures how many standard deviation an observation is away from its mean. So the reason why we have the z-score is because we have what we call variance. I said earlier that the variance is the spread and the middle of the graph is the mean. So if you want to find a z-score, we want to find the number of time that the variance is away from the spread. Sorry, the mean is away from the spread. So we have a positive z-score. If the z-score is positive, it means that it is around the region of the mean. If the z-score is negative, it means that it is below the mean, that is, it is moving to the left hand side. If the z-score is positive, it is moving to the right hand side. But if the z-score is 0, it means it is at the center. Are you getting me? So we have a curve, we have the middle part, we have the left hand side, we have the right hand side. So to the left hand side, it means that the z-score is negative. To the right hand side, it means that the z-score is positive. And when it is at the center, it means that the z-score is equals to 0. And there are practical implications to this. The standardization allows us to compare values from different normal distribution, or to use a single standard normal table for all normal probability calculations. So those are the practical implications. Are you getting it? Now we have the 69, 95 and 99.7 rule. Now the 68 means that the standard deviation, we have one standard deviation away from the mean. That's the 68% rule. Then the 95% rule means that we have two standard deviation away from the mean, while the 99.7 means that you have three standard deviation away from the mean, and they have their respective values. So you can see 0.68, 0.95, 0.997. So there are visual representation for this, which are already sent to the platform. Are you getting me? Now, all of these things that we've stated now, let's come to the application. Now, one example that we have is, suppose the height of adult males are normally distributed. They are normally distributed. The word normally distributed means that you are dealing with a normal distribution with a mean. So it means that the mean at the center is 175. Now it means that the average height of people that we have there is 175 centimeter. That's the mean. That's the average height of people. Now they are now outliers. They are now deviations. Right? Now there are deviations, that is, there are either some people that are greater than, that their height is higher than 175, and there are other people that their height is lesser than 175. So those guys are called the deviation, or they are called the standard deviation. So if you take their square, that's their variance. So they are deviating, as the word implies, they are deviating from the normal mean. So if something is deviating, it simply means that either it is increasing or it is decreasing, but it is not equal to the particular size. That's what we mean by deviation. So it is standard deviation. So we want to calculate their respective z-score. Now, by calculating their respective z-score, I said earlier that you'll be calculating the negative part and the positive part. So you add +7 and you subtract +7 from the mean, which is 175. So when you subtract 7, you have 168 centimeter, and when you add 7, you have 182 centimeter. So this means that you have an approximate value of 68% of adult male. Now, why do we have 68% of adult male? Because they are still within the region of one standard deviation. It's just one standard deviation. Then when you move to the other part, you move to two standard deviation by multiplying 2 times the deviation, and add and subtract. When you move again, you keep on moving, but in this case now we are moving just 3 times. Right? So by the third standard deviation, we have 3 times 7, which is 21, and we added and subtracted, and that gave us an approximate value of 99.7%. So this simply means that those values that we have, they are the standard value. That is why they are called standard deviation. They are the standard value. If it is at the mean, it is 68%. If it is at the if it is 2 standard deviation away, it is 95. If it is 3 standard deviation away, it is 99. So that's their constant value. So you don't need to ask me whether where are those values coming from. Those values are standard. They are like that. Are you getting me? So now let's use the standard normal table, the Z table, to calculate our results. So the Z table or standard normal table provide what we call the cumulative probability. Now when we say cumulative probability, it means that you can see that we have two values, we have two functions. We have capital letter Z and we have small letter z. Now for various values of z, I mean the small letter 1, the small letter z, it is the area under the standard normal curve to the left of a given z score. So to the left, so we are saying that the standard normal distribution is to the left of z, is moving to the left. If it is greater, it means that the standard normal distribution is moving to the right. Are you getting me? So there are different tables. We have different tables for this, but if you want to calculate a standard normal distribution, a typical z table provide probability of z less than z. So that p there means probability of z less than z. So let's take an example. So the first example which I gave, which I already sent the graph to the group, is probability of z less than minus 1.23. Now if you check the graph that I sent, we have the left hand side, the vertical side of the graph, and we have the horizontal side of the graph. And by doing this, it means that we calculated probability of z less than minus 1.23 to be 0.1093. So maybe at the end of this video, I'm going to put the graph how we got minus 1093. So I'm going to show you the graph at the end of this video. So you hold on, you must watch this video to the end to see the end point, how we got minus 0.1 minus 1093. Are you getting it? Now for those of you that don't have the graph, you must download a standard normal distribution table. You can go to Google and download standard deviation table, standard normal deviation table, or standard normal table. So once you get there, you download it. Now you are going to trace these values. You are going to trace -1, and you -1 to the vertical side and 0.23 to the horizontal side. Just like when you are finding values on table of figures. So you are going to use that same approach, that table of figure that you used during your secondary school days. So just like the same way you find those values, you are going to find 1 on the vertical side, on the left hand vertical side, and 0.23 on the horizontal side. Then you now trace the value. So whatsoever value that you get, that is how we got 0.1093. Are you getting it? So now that value, this means that when you take their percentage, the percentage of that thing is 10.93% of the data in a standard normal distribution falls below minus 1.23 standard deviation from the mean. So the second one that we have now is that, now before you can even know, you must note that whenever you see z is normally distributed to 0,1, the first thing that should come to your mind is that you are dealing with a standard normal distribution, because I stated earlier that for a standard normal distribution, their mean is equals to 0 and their standard deviation is equals to 1, or their variance is equals to 1, any one. So the second part says that probability of z greater than equals to minus 1.23. Now if you have a greater than sign, now greater than or equals to means that is either it is equal to minus 1.23 or it is greater than minus 1.23. So that's what it simply means. So this means that the total area, both left, both mean, both right, all of them together, they are equal to 1. Are you getting me? So for every probability question, the sum of all probability questions usually sum up to 1. It can never go above 1. So if that should be the case, it simply means that the z greater than minus 1.23, that minus 1.23 is representing that small letter z that you have there. So if you want to rewrite it, you have to write it by subtracting it away from 1. Where is the 1 coming from? The 1 is the standard value for a probability situation. So for every probability question that you have, any question that you see that is having p open bracket z greater than equals to z, small letter z, it is always equals to 1 minus p z less than z. So that is a standard formula for finding probability of a normal distribution function, a standard normal distribution function. So by doing that, we already found our value earlier from this other part. We already found probability of z less than minus 1.23 earlier to be 0.1093. So when you subtract it, when you take it away from 1, you have 0.8907. Meanwhile, there are other ways you can find this from the table. There are some situations whereby you don't need to subtract it away from 1. You can easily find that value from the table directly, and you are going to see it from the table. So I know this is a bit complicated, but once you take your time, you get to understand most of the concepts that I've been explaining so far. Alright, so let's move to example 2. So example 2 says that given S is normally distributed to 3,49. Now, immediately you see S, what comes to your mind? This is a normal distribution question. It is not a standard normal distribution question, because what you have there is X and it is not Z. But if it is Z, what should come to your mind is a standard normal. So, and for a normal distribution, there is something called z-score, which I already explained. So the z-score formula is x minus mu, which is the mean, over sigma, which is the standard deviation. So the x is given. From that question now, you can see that the mean is 3 and the standard deviation is, the variance is 49. Now, but what we have in the z-score is a standard deviation. So you have to take the square root of the 49 to get 7. And it means that our z-score is going to be x minus 3 divided by 7. So the probability of x less than x will therefore be equivalent. Now we are now converting the normal distribution to a standard normal distribution by introducing z now. What we found is z-score. So, and finding z-score means that you are navigating from a normal distribution down to a standard normal distribution. So that becomes probability of z less than x minus 3 over 7. So we have some specific case. Specific case says that if you have to find another format of which you can find probability of a question like this is when you are asked to find probability of x less than 7. So that capital letter X means that you must use the approach of a standard normal deviation, which is 10 minus 3 over 7, 7 over 7, which is equals to 1, which this is a proof that it is probability in nature. Are you getting me? So that is that for all of the cited example in the note. So quickly, let's check the last part. So the last part is, why is the normal distribution important? Natural phenomenon, statistical inference, central limit theorem, quality control, finance. For those doing economics, you get to know what you mean by quality control, central limit theorem. So this is where we'll stop. So for those, this is where we stop for chapter 2, lecture 2 of of Math 162. So those of you that have not watched chapter 1, kindly go back to the video, watch chapter 1, then come back to this and watch this as well. Thank you.